For this problem, we're asked to find, or to graph, I should say, the sine of x. And this one can be a little complex, but not too bad once you get a little hang of it, okay? Again, we're going to go back to our unit circle. This is going to be key to what we're going to be doing for our trigonometry unit. And the sine of x, and let's look at here the sine. Remember that sine are all of our y values. So the sine of x, let's see, as we go throughout this, let's identify what this is. At 90 degrees, my y value is 1. So at 90 degrees, what I'm going to do is I'm going to put a little dot here right at 1. Okay, and then at, let's say, 180 degrees, it goes down to 0, my y value. So I'm going to put at 180 degrees, it's going to be 0. And then I'm going to come around here to 270 degrees, and at 270 degrees, it is negative 1. And then, of course, if I come all the way around here to 360 degrees, I am at, my y value is 0. Okay, and of course, so now what we're going to do is we're going to draw these, and it's going to be a curve here. So you're going to do the best you can to draw this curve. This is my freehand, so don't judge, but that is my sine of x, and it continues on, right? I mean, it's not just a little one, but it continues on forever and ever. All right, now, with that information, we know what sine of x is. What if we did, what is the sine of x minus 1? Okay, so what we do is we find the sine of x, just like we did here, and then we're going to subtract 1, meaning we're going to move all this down 1 unit. So instead of right here being at 0, it's going to move down to negative 1. Instead of right here, the 90 degrees being at 1, it's going to be right at 0. Okay, let's graph what that one looks like. So this is the exact same graph. All we did is we moved it down 1 unit. Right at 270, we were at negative 1. At 270 here, we are at negative 2. So we just took the sine of x graph and subtracted 1 from it. Well, what if I did 3 times sine of x? And this one's scaled just slightly different, but we know what sine of x is. So all we're going to do is find sine of x, and we're going to multiply that by 3. Okay, so at 90 degrees, let's see, here we go, 90 degrees, instead of it being at 1, it's now going to be at 3. Let's see, at 180 degrees, it was at 0, so 0 times 3 is 0 again, that doesn't change. At 270 degrees, I was at negative 1, so 270 is now going to be at negative 3. At 360, I was at 0. So I move back up here, 360 is at 0. And I continue this trend, right? So this is basically the same sign, only it's kind of stretched. Everything's multiplied by 3, and I will connect all of those dots to make my graph. Well, we could spice it up even further if we wanted to. A fourth sine of x. So this is the same principle that we were using here. We're going to take whatever sine of x is, and we're going to multiply by 1/4. So when we come along here at pi halves, which was 90 degrees, we were at 1, but now we should be at 1/4, right? This is half, this is a full one. We're going to be at 1/4 of that. When we get to pi, which is otherwise known as 180, we were at 0. 0 times 1/4 would still be 0. At 3 pi halves, which is 270, we were at negative 1. Now we're going to be at negative 1/4. And then 2 pi, of course, we're going to be back at 0. So we're going to connect this graph. The graphs look very, very similar. Now this one's just kind of, instead of stretched, this one would kind of be shrunk down, if you will, because it's 1/4 of what we used to be. Let's do just a little bit more practice on this. So if I go sine of x minus 1, that's one we kind of graphed earlier there. Now let's look at this one. This is 3 sine of x plus 2. Okay, so we're going to do the sine of x. We're going to multiply that by 3 and then add 2. All right, there are a couple different ways you can do this one. You could just take whatever the sine of x was. At 90 degrees, it was 1. Multiply that by 3. That would be 3. And then add 2, which would be 5. So I could go 90 degrees is going to be at 5. And then 180 degrees, well, let's see, 180 was at 0 times 3 is 0, plus 2 is 2. So that's going to come down here to 2. We could do that if we wanted to. I'm going to show you a different route as well, just in case you wanted to do that. This is the graph at 3 sine of x. We've already drawn this one, so I'm going to move fast through that portion. Now what we're going to do is essentially what's happening here is we're taking this entire graph of 3 sine of x, and then we're adding 2 to that graph. So that means we're going to move this entire graph up 2 units. We're just going to take that whole graph, move it up 2 units. Same exact graph, we're just moving it up 2 units. And that is 3 sine of x plus 2. Let's use that same method for this one. We've got 1/2 sine of x minus 1. So I draw my 1/2 sine of x first, right? Instead of going all the way up to 1, I only go to 1/2. Instead of coming down to -1, I only go to -1/2. Okay, so this is my graph of y equals 1/2 sine of x. Now I take this entire graph and I subtract 1. So I just move all this down 1 unit. Move this entire thing down 1 unit. Okay? I'm moving it all down 1 unit is all I'm doing. And that's my graph. Okay, so hopefully that's helpful.